in terms of like setup. There's not like a bunch of fancy like steps or anything. This is the plate reader itself, and it's connected to the computer with this USB port and this like wire. I can think of the word. So in order to get started, you just turn it on, and then the program that we actually use to do the plate reading is this blue icon with like that looks like a plate. So you just double click it. Give it a second. Okay. So then, in terms of actually like creating a protocol and doing like running experiments day to day, the easiest way to do that and sort of keep everything organized is to use like a defined protocol that you use for all of your experiments. So before you get started and doing an experiment, go to protocols, create a new one, and then if you click this icon with the like blank sheet and the play button, you can do any number of steps for any number of time, and it's all defined by you. You can do a variety of things. Mainly a lot of people are doing like readings, and we can do absorbance, and you can define the wavelength here, and this is in nanometers. You can also do fluorescence, where you're sort of limited to specific excitation and emission wavelengths that the plate reader can achieve. And then you can also do luminescence, although I haven't done it, so I'm not exactly sure how to do that. But I think mainly people, when they're doing measurements, are doing absorbance. And then I'll just press OK, and then it places it in order. And then I can also add other steps, such as warming up to a specific temperature if I'm running like an enzymatic reaction at a specific temperature. And I think this goes up pretty high. I haven't gone above like 40 C, but I don't think anyone who does enzymatic stuff would anyways. And then you can also have shaking steps where you can control the speed, and this essentially just mixes your samples. Or if you're taking a reading of cells and you want them to be suspended in solution, then you can add a shaking step. And then you can also, again, define however long you want. And you sort of just get this protocol. And then as far as the plates that we use to run on the plate reader, they're all above the floor centrifuge in that room. And we mainly use 96 well plates or 384 well plates, but I think you can sort of configure whatever you want here. And usually the default for these, like the 96 well and the 384, are fine. We specifically use like a CoStar 96 for the 96 well plate, but I think if you keep it as default, it should be fine. And if you also want to prevent evaporation, you can just press use lid if you have like a plastic lid. I also have some plastic seals that I use when I'm doing like long experiments at high temperatures to prevent evaporation. And then the other important thing with the plates, shoot, I lost my train of thought. Okay, I'll try to remember. Oh yeah, so a really important consideration, you can technically use any 96 well plate for the plate reader. Like technically the mass spec plates could be used, but you want to make sure, especially for any like absorbance readings or things like that, that the plate is clear on the bottom. That we have a couple plates in that room above the centrifuge that are kind of like an opaque white, or they're completely like solid white. So all of those will interfere with your measurements. So just make sure that the wells are clear. Huh? Yeah, but you can control, Agnella apparently said that you can control where the light comes from, but I think mainly all these are defaulted to be read from the bottom up. But I think you could technically do top down. Yeah, so once you have your actual protocol definition, or protocol defined, okay. Well, usually it doesn't give me this error, but I think this is, depends on the steps, if they're in the right order or things like that, but I'll just ignore it for now. I'll just save my protocol. So I'll go to File, Save As, and then I'll just collect, I don't have a folder, but I'll just save analysis. And then once I have my protocol defined, I have to close this window and then reopen it. And so I go to Experiment, and then I'll create an experiment using an existing protocol, and then I'll go to the actual protocol that I just made. But I'll click a different one actually. Yeah, so basically having a defined protocol just helps in terms of saving the data later on. So you can basically take multiple runs on different days, and they'll be automatically sorted by whatever you named your experiments as. So it's just easier than doing all of your runs in just like the same protocol, or else you'll just have like a bunch of readings that don't really have labels and don't really make sense. So once I have my protocol open and my experiment opened, and I'm ready to actually get started, I'll just press this big green button. And then I just have to define or name my experiment. So I'll just name it something random. Okay, this is a common issue actually that I didn't. Okay, so it says the COM port doesn't exist. So when one of these issues comes up, you go to System and you go to Instrument Configuration, and you go to View Modify, and then here you want to make sure that all the parameters are correctly displayed. So the type of plate reader is the Synergy HT, so that's correct. And then this is usually 9600. It doesn't really ever change, but this is the main thing that usually is the issue, and it did say that the COM port doesn't exist. So I have it set as 1, but if you go back here, which I won't get back in there, you can see that this wire is connected to the plate reader in the communication port that says communication port 3. So I just need to change this to 3 and press OK, and then it should be fine. So, oh, actually, I'm going to reopen that window. So go back to System and Instrument Configuration and go to View Modify. And if I press this button, it says Test Communication. I'm basically checking if the plate reader is properly connected to the computer. It usually takes just a couple seconds. Yep, and then it says the reader is communicating, exclamation point, yay. Everything's good. So everything should be fine. So if I press the green button again, and give it some time to prime itself. Yeah, okay. So for this specific protocol that opened, I'm measuring fluorescence. So the fluorescent bulb that's inside the plate reader usually takes like around 3 minutes to warm up. I'm just going to override it for the sake of this. And then I also have the protocol definition to heat this up to 37C. That usually takes around like 20 minutes. It could take longer depending. So if you're like booking and you are considering that in your experiment, just make sure that you sort of start this before you actually start aliquoting or making your master mixes or different parts of your experiment, because it usually takes a fair amount of time to warm up to 30C or 37C. And then when I'm ready, I would get my plate, put it in this cartridge here, and the important thing here is that A1, you can see like right here, it's like kind of dark, but there's like, it's imprinted. You just want to make sure that your plate is oriented correctly into the holder. And then I would just press OK, and then it would read for however long. Okay, and then a common issue that comes up when multiple people are running the plate reader, especially when people are running back to back. So if I go to run a different experiment, this is someone else's experiment, hypothetically. So this is a common thing too. It just says that the COM port is in use by another application. So it usually just means that someone else was running or someone else's data was like taking up the plate reader's time. So just close out this other window and then try again. And then it should be totally fine. Okay, and then one other troubleshooting thing. That, okay, I'm just going to turn this off. So let's say I'm trying to get it started, and the plate reader, I just turned the plate reader on, and I'm trying to start a new experiment. So it just says the reader's not communicating. It just means that you didn't give it enough time to warm up, or there could be a different issue, but usually that's the main issue. So usually just give it some time to set up, and then if you want to check that if it's ready or not, again, just go to System, Instrument Configuration, view modify, and then you can test communication with the system. Okay, and then as far as exporting data goes, we normally just use like an external USB drive and plug it into this port. You just want to make sure that you don't unplug either of these USB ports, because this one is the NanoDrop and this one is the plate reader. So that just messes things up for future runs. So when I want to export my data, I'll just open my experiment. And then for this specific experiment, I did multiple readings. So sometimes you'll be reading like 2 different absorbances or multiple measurements. So I just go to this drop-down menu and I can look at different parameters that the plate reader read for each of my wells. Oh, and I forgot to mention, when you're doing your actual procedure, pretty much every single time you're doing it, you're going to be looking at different wells in your well plate. So you actually have to go to your procedure every single time and define the space where you want to measure. That's very important, of course, or else the plate reader won't know like where to measure. You can of course like read your whole plate, but kind of doesn't need to happen. So, and then okay, so for exporting data, I can just click a single well, and then I can select all the wells that have the data that I'm interested in, and then I can go to data, and usually we just copy this over into Excel. And then here, Control-C doesn't work, so just make sure to right-click and press copy to clipboard, or else your data just won't be copied. And then I think the last thing